Let's jump straight into this explainer. Most derricks handle one job at a time, right? Well, today we're looking at a structure built to run two simultaneous dynamic loads. We're talking main well operations and auxiliary well operations happening at the exact same time in the exact same tower without either interfering with the other. This isn't just a nice convenience feature, it is a deliberate design choice that literally slashes well construction time. Think about the sheer magnitude of what we're doing offshore. We're hoisting tens of thousands of feet of incredibly heavy steel pipe, trying to connect to a wellhead miles underwater that is actively containing intense pressures. Standard, single-job derricks, they just fall short of today's efficiency demands. You simply cannot afford to do everything on a single linear timeline anymore. You absolutely need to run those two dynamic loads at once. So, here's our roadmap for today. We're going to cover breaking the linear timeline, defining what dual dynamic actually means, looking at the anatomy of the derrick, managing those structural stresses, and finally, operational limits and warnings. Okay, kicking things off with Section 1, breaking the linear timeline and how we escape the sequential trap. 907 metric tons. That is the lifting capacity on the main wells alone. It really shows you the staggering raw power required to hoist those heavy drill strings and marine risers. Just to put that massive number into perspective, that's the kind of continuous capability you need to handle 10 to 12,000 feet of marine riser pipe, and do it without breaking a sweat. But here is where it gets really interesting. Right beside that main well, we've got 680.4 metric tons of capacity on the auxiliary well. Having both of these massive capacities housed in the very same tower means the rig can do offline pipe handling or pickup casing right alongside the main operation. It's an absolute game changer. It compresses that complex well program timeline, gets you out of the sequential trap, and saves literally millions in day rate spend. Moving right along to Section 2, defining dual dynamic as a true structural engineering achievement. We need to clearly define the star of the show here. The NOV dual dynamic derrick is the main load-bearing tower. Now, the insight a lot of people miss is that dual dynamic isn't some slick marketing term. It is a strict structural engineering distinction. The foundations, the steel connections, the whole shebang, they're specifically calculated to physically support and guide hoisting, rotating, and pipe handling loads for both wells at the very same time.
And here is a super crucial distinction. A lot of folks assume dual just means doubled capacity. Not quite. A structure rated for a double static load, meaning it can just hold the weight, could actually buckle or fail if those loads start moving at the exact same time. If the loads can't move dynamically together, you're still stuck waiting around. True dual dynamic means the steel is mathematically calculated to handle two independent, moving loads acting on the derrick simultaneously.
Think of it exactly like a two-lane highway bridge. A single-lane bridge might be able to handle the total weight if you parked two heavy trucks on it, right? But only the two-lane design lets two fully loaded trucks cross at the exact same time without one having to stop and wait. That is the essence of true dynamic capability. Let's head into Section 3 and look at the anatomy of the derrick and its physical components. The derrick isn't just a rigid frame. It's essentially a sheltered ecosystem made up of specific, essential components. We're looking at the setback area where the pipe is racked, the hardwood timber decking that lines it, the V-doors for pipe transfer, and the wind walls that protect everything. Which brings us to Section 4, managing structural stresses, focusing on the physics of the deck. Okay, so this sounds totally counterintuitive, right? You're on a 6th or 7th generation drillship, packed to the brim with dynamic positioning software, AC electric top drives, advanced robotics. So why on earth does the setback area rely on simple, traditional hardwood timber decking? Well, it all comes down to the physics of point load distribution. Basically, the stress on the deck equals the total racked pipe weight divided by the contact area. Drill pipe stands are insanely heavy, and they sit on a very small footprint at the bottom. Hardwood serves a brilliant, vital mechanical purpose here. It takes that highly concentrated point load of the vertically racked pipe and spreads it over a much wider footprint. This dramatically reduces the peak stress on the underlying structural steel deck, preventing local damage. Then, we have the V-door. This is the angled opening right at deck level. Think of it as the necessary geometric pathway to feed these hungry dual operations with the raw steel they need. It basically acts as a ramp to safely and efficiently slide the drill pipe up from the horizontal catwalk and right onto the derrick floor. Of course, we're operating out in the open ocean, so weather is a massive factor. Wind walls are your essential structural shields. When you're maneuvering these long, 130-foot stands of drill pipe, they literally want to act like giant sails if the wind picks up. The wind walls shield the derrick floor, keeping the wind loading down and protecting both the personnel and the mechanized equipment dealing with those massive suspended loads.
Finally, let's wrap up with Section 5, Operational Limits and Warnings. We need to ground all these amazing specs in reality.
Here is a really critical warning for any operating engineer out there. Yes, wind walls are deployed, and yes, they absolutely protect the floor. But once that suspended pipe is hoisted high up into the tower, it is still acting as a sail aloft. Wind walls reduce the wind loading, but they definitely do not eliminate it. Operational wind speed limits for pipe handling must always be respected, no matter how good your physical shielding is.
And I really want you to take away this human element check. The structure is rated for dual dynamic activity. The steel can absolutely handle it. But the ultimate safety mechanism on a dual dynamic derrick isn't made of metal. It is the coordination between the main and auxiliary crews. Strict scheduling and hardcore communication discipline are what actually prevent catastrophic load conflicts when you have two massive operations happening side by side.
So, knowing the steel can take the stress, I want to leave you with this final thought to chew on. How does a crew maintain the flawless, split-second communication required to run two massive, completely independent listing operations just feet away from each other without a single collision? Because at the end of the day, even the most incredible structural engineering in the world is only as good as the human beings who orchestrate it. Think on that. I really hope this explainer gave you a powerful new perspective on what it takes to build the modern offshore well.